Welcome everybody, happy holidays. Welcome to the December Atlanta Java User Group meeting. As usual, we have Venkat here, who comes every Christmas to visit us. Today we're doing a hybrid style event, as you've noticed in the last few months. And we're going to be doing an Ask Me Anything type of thing tonight. So if you have questions, please pop them into the YouTube chat, and we will try to answer all of them. We'll be here for the next 2 or 3 hours, and we should have plenty of time to answer your questions. Of course, we're not going to be here for 2 or 3 hours. We're going to try to wrap this up about 8 Eastern. So let's just do a few quick announcements, and then we'll get into the Ask Me Anything with Venkat. So first of all, we'd like to thank our sponsors for making it possible to have Venkat here and to do all the other things that we do for the Atlanta Java community. Of course, we're going to do an AMA with Venkat in a few minutes, but we just opened the tickets for DevNexus 2022, which we are at this point planning on doing in person at the Georgia World Congress Center downtown. And that will be not in its normal February dates that we do, third week of February. We will be doing them in the second week of April. Again, it will be in downtown Atlanta at the Georgia World Congress Center, our usual venue. So please do sign up. We're all very hopeful that we will be able to have an in-person show, and we are planning for that currently. Okay. And without further ado, I'd like to introduce Venkat, and welcome. Thanks you for coming again. So how was your trip here? Was it, you enjoying the Atlanta weather? It's cold and rainy here, unfortunately. It seems like it's always like that when you come here.
Well, thanks for having me here, Pratik. It's a pleasure, and thanks for everyone. I hope everyone is staying safe and doing well. It's always a pleasure to be here in Atlanta Jug. This time being hybrid, but hopefully things get better as we move along. But yeah, I landed and I saw clouds in the air and rain. I said I should be in Atlanta in December, so it feels like it should. So it's great to be here.
Thank you again for coming, especially in these uncertain times, or whatever you want to, whatever we call them nowadays. So let's see if there's any questions from the audience to get us started. If not, we have a few that we've already lined up. So nothing yet, but one of the things that we've been talking about quite a bit at where I work is around Java 17, of course. But I'm not going to ask you about Java 17. We're going to throw you a curveball and see if you can hit the curveball today. Is there anything in Java 18 that you've seen that looks interesting so far?
Well, there are, let me kind of broaden that question. There are a few things that I'm eagerly waiting for in the future versions of Java. I'm not going to tie that to 18 or, generally speaking, a particular version number. And I would say there are 3 things I'm really eagerly looking forward to. This reminds me of one tweet. As you know, I get excited about just about anything usually. And there was one day I was working with, I guess, Kotlin and JavaScript together, and I tweeted saying, today's tweets are sponsored by destructuring and or deconstruction. And Brian Getz, the Java architect, replied back saying, I will neither confirm nor deny if Java will have destructuring. And I replied back saying, I think I know the answer. But he went on to actually explain the different types of destructuring and why one is more important than the other. So that kind of was, I think that was about 1.5 years or 2 ago, and I've been anticipating that quite a bit. The real...
Hold on. Let me slow you down for just a second,
yep.
Venkat. So for the people in the audience here, and also the people listening at home, just give us a quick elevator pitch on destructuring.
So let's tear up the word destructuring into 2 words, de and structuring. So structuring is basically taking properties and putting an object together. So destructuring is the opposite of it. So you pretty much you're saying, I've got an object that came in as a message. I want to tear it apart into properties, but let's do that, fluently, elegantly. So rather than having to write multiple lines of code, in a very elegant, powerful way, you can extract the properties you want. But not only can you do that at the point of where you want to pull those properties out, But the real power is you can do that when you send an object to a function where the function only requires a certain attributes. You can just pull them out while you're destructuring. A concept that's been provided by languages like Haskell and Erlang for a long time.
And Clojure.
And Clojure as well. And that's kind of what makes it exciting is that you're able to write code very fluently while you're trying to extract. And more recently, JavaScript introduced it, Kotlin has it. And the real beauty of this is we're going to be able to do that with Java, but also combine that with pattern matching and also records. I think that's where the real power is going to be. So a few features that's been coming up in the more recent versions of Java really are the pathway towards really that elegant pattern matching and destructuring. So that's definitely, first thing I'm excited about destructuring. The second is a very amazing pattern matching syntax, which is going to show up very quickly in Java. And then, of course, going a little forward into it, I'm really waiting for and anticipating Project Loom, which is going to make a big difference as well. So 3 things I'm really excited about.
Testing. They say that this isn't on. Is it on now? Okay. Sorry. So for me, when I think of destructuring, for some reason, I always default to how Clojure does restructuring. I mentioned that already. And Clojure is a purely functional programming language, as you know, which, if you're not familiar with Clojure, it's a Lisp-based programming language that runs on the JVM and has, obviously, Java interop and stuff like that. So you mentioned a second ago how it works really well with kind of functional programming in general. But are there any specific examples that you have around how this destructuring would look like, for example, with lambdas in Java?
So I don't know exactly whether
what it's going to look like.
Yeah, right.
We don't know what it's going to look like.
But having said that, though, I can definitely relate that to languages like Scala, where that's being done. And a little bit of hesitancy to say that because Python is one example where they actually pulled it out. So this is where it becomes tricky with languages and features. Both Scala and Python gave you that ability, and even in Groovy you can do this. So let's say, for example, just one example is, let's say you want to iterate over the elements in a map. Just a very simple example. So as you're iterating through elements in a map, you get a map entry, and then you want to pull out the key and the value. Well, you don't have to do that. You can just do the destructuring at the parameter, and as a result, you have the key and the value as separate variables that get pulled out. You can do that in Scala quite effectively today. But like I mentioned, Python decided to remove that feature actually in more recent versions.
They removed it in Python 3, right?
Correct. Right. Yeah. And so, but to me, that's something that's pretty elegant. I really like it because it removes it does 2 things. One, it removes that ceremony or the extra effort, but it also makes it more natural to think, right?
That's exactly what I was going to say. Again, I'm going to use Clojure as an example. When I was writing Clojure and I was doing destructuring, it actually felt very intuitive, and it was just like, this just works and it makes sense. I don't have to think too hard about it, right? And for me, at least, I'm not as smart as you, so I can't think too hard about my code. Otherwise, I'll forget everything I'm doing. Anyways, go ahead.
Yeah, and that's exactly the reason I really like it is, but my aha moment was, I was writing JavaScript one day, and I have this, I was doing an optimization problem. And in the optimization problem, we were doing recursions to get different results. And when we get 2 results, we need to merge them together. And I was writing the code to merge these data. And it occurred to me after having the test pass, I said, wait, I can actually refactor this. And then I started refactoring it with the destructuring and default parameters. And a little light bulb goes in the head. So like, that's cool. Because if the value exists, use it. If not, give a default value to it. So while destructuring, you can also use default parameters, and that makes the code more concise. And the place where I was using this actually was in an optimization problem. And so when you're working with a problem, you're like thinking, how could I make the code more concise? And suddenly you're able to pull these concepts together. And that's kind of where you're like, that's nice. You're not fighting the syntax at this point. You're being very expressive, and you get to make the code more intuitive. And what was 4 or 5 lines of messy code just fizzles down to 1-liner, and then that's always great.
Excellent. So if anybody in the room has a question, we have a small audience in attendance. If anybody has a question, please raise your hand. We're happy to take them. But Venkat, we're going to shift gears for a bit because we jumped straight into the deepest part of the pool with that question. And we're going to bring it up a bit and say, ask this specific question from Nirajan, who says, any advice or tips for writing a book?
Oh gosh, we were just talking about it.
I'll start with my advice. Don't do it. You go next.
That's a good advice.
I've written 3 books, and neither one of them, none of them were I'm going to do this again moments. So please, after you.
That's a. We were just talking about it. In fact, Niraj, that's a good question. I'm going to say I'm either in my 13th book or the 14th book right now, writing the next one. But the first thing I would say is, I'll go back to the story of, when I started writing a book. I won't mention the name of the person right now, but somebody I deeply respect, a really good author. And I went to him and I said, hey, I want to write a book. What do you think? And his first question was, how's your business? I said, my business is great. I'm busy all the time. And he said, don't bother writing a book, because a book is a big-sized business card. If you have a good business already, why are you wasting your time? And I took his advice. I said, thanks, I'll not write a book. And then about 6 or 7 months goes by, and I realized while he is correct, he was not complete. There is another reason I think we want to really write a book, and at least that's for me. And that is, you want to write a book because you have a story to tell. And the reason I emphasize that is, when you feel you have a story to tell, nothing is more motivating than that. I was talking just a few minutes ago about writing a book, and the first question I asked him is, why do you want to write the book? What's your plan on it, right? What is the reason for it? Right. And what he shared with me was exactly that. He had a story to tell, and he said, here's the reason I want to write a book. That is the key, right? So don't write a book because you want to write a book. Write a book because you got a reason to write a book. Right. You got to have a story to tell. Right. Don't write a book for fame and fortune. Oh, right? Yeah, and you get neither one of them, at least not in the beginning. Right, not in the beginning. That's right. Yeah. That's right. So that was a good way to not answer the question. No, I'm joking. But for the person who asked the question, and for other folks who are interested in this, you can do. You don't have to do much Googling to figure out what the process is for doing it. And there are easy ways to do on-ramps. You can DM on Twitter either myself or Venkat, and we can help you down this journey if you want to go down that road. So we can give you some tips. And well, at least for me, one of the other things that I realized was, once you're self-motivated, you don't need others to tell you need to write a book. So most of the books I've written over a 2-week period. I would just... Yeah, sorry, Venkat, most of us can't do that. Well, and basically, you start when you wake up and go to bed late, and you keep hammering on the keyboard for 2 weeks at a stretch. The key is get a first draft out very quickly, and don't make it perfect. Don't write the book you want to publish. Do a core dump, write a first draft. And then once you do, publishers, I was saying this, I don't have a specific statistics on my hand, but one of the things that publishers know is maybe 60% of the proposals they get never make it into a book, because the author eagerly signs up, and then life happens and work happens and they disappear. So if you have a draft, however initial that is, you're telling the publisher you already have a draft. That's huge. And I don't think I would have ever been accepted to write a book if I had not written my first draft already. And that's what I would recommend is just plow through and write your first draft. Then go find a publisher. That's much better. Right, and I think there's a bit of advice that somebody gave me a while back, which was, if like you said, if you're motivated to write something and you're motivated to tell a story, the best place to start if you've never written a book is actually just start writing and publish some of it as a blog. Right? There are people who've had great success publishing many articles on their blog, but not necessarily making it into a quote-unquote book. Right? So that's also a great way just to dip your toe in the water and say, okay, let me just write 3 or 4 long-form articles and see how that goes. And because you own that, you publish it on your own blog or something, you can always take that material and expand upon it and do a full book proposal or do a full book draft, right? Totally. And the last thing I would say is, if you ask me about a lot of things I've done in my life which I consider to be, gosh, this is hard, I would definitely put writing a book as one of those. Every time I write one, I tell myself I will never do this again. And then a few months later, I just don't remember. I guess I have a short-term memory. I get back into it, like, I should write a note, don't do this again. So to your point earlier, right, don't do it. It is hard, and you should be willing to endure through that.
Yep. And getting some practice writing some blog articles is a good way to start. So, all right, let's see what else we have. All right, so we have one from Nirajan R. He says, I code in multiple langs and often mix them and wonder why is the computer erring? But you notice, hold on, let me try to. Okay, right. He says, thanks, Glenn. The rest of the question is, but when you switch between different languages, how do you not confuse them? So apparently he's seen you present before in multiple languages. So, and I think we all face this, right? Because as a modern developer, we don't just code in Java, right? On any day of the week, we're coding in Java, shell scripts, maybe SQL, and God help you if you're also doing YAML on top of that. You know what I mean, right? Yep. So how do you, the question is how do you not get confused between the different languages when you're actively coding or when you're doing a presentation?
So the real honest answer is I do get confused, I just don't show it. And in fact, I'll share with you a story about this. There's a show called .NET Rocks, and they call it a TV show, but it's really not. It used to be back in time streaming. And I had just spoken at a conference where I've been coding Java all day long, and .NET Rocks, as the name indicates, is a C# related show. And I finished my talk literally at 4:45 in the evening, wherever I was speaking. I sign in at 5 o'clock, and then I log in, and the host is asking me to talk about some examples. And I start writing the code, and he just begins to laugh, and the code doesn't compile. And then he says, okay, folks, a quick introduction. Venkat programs in multiple languages. We'll cut him a slack now. I was writing Java syntax for C#, and obviously, there are some syntax differences. So it takes a while to shift that. And even today, I would write JavaScript syntax in Kotlin or try to put a semicolon or not put one. It happens. And it's okay to get confused. There's nothing wrong with it. We're not in a competition. But what is really important is I almost never focus on the syntax, because when you are getting confused, you're getting confused on the syntax. What I always focus on when I learn a language and when I use a language is the semantics, not the syntax at all. So for example, if I'm using Scala or Kotlin or JavaScript or Clojure, my question is, how would I design with that language? What are the semantical things I need to think about? When it comes to Kotlin, maybe I want to think about using delegation properly. Or maybe I want to use inline functions to leverage some of those ideas. Or if I'm going to be using lambdas, I want to think about, how do I design with lambdas in Kotlin to get the best performance or maybe a best design. So I always focus on the design and semantics. And once I realize, and the beauty of this is, we often get confused with the syntax, but we very rarely get confused with the semantics, because there are only a fewer semantics that are available, and you can use them between languages. And then once we leverage that, shamelessly look up the syntax. There's nothing wrong with it. And as an example, a month ago, I was teaching a course on design. I was using Java predominantly. But one of the person in the audience said, hey, but I would do this in C++. And I said, well, that wouldn't work in C++. And then this is a person who programs in C++. And he said, really? And I said, yeah, it won't work in C++. He's like, show it to me. And I'm like, okay, now I got to program in C++. And I haven't done C++ in a few years now. And I said, well, I will show it to you, but you need to help me here. And I started writing C++ code. And every few lines I would say, help me out here, what would I call here? And I mean, this guy is programming every day. He's like, oh, you would do it. Like, that's right, I remember now. And that's perfectly fine. And I was able to show the idea because I know the semantics. So I was able to tell him it won't work. But I knew the semantics, but I don't have the syntax in my memory. But he helped out with the syntax, and I helped with the semantics. And in the end, we had something that we were able to discuss upon. And that's exactly what I want to focus on, is the semantics. And then once you really nail the semantics and make it strong, the syntax can come and go. That's not a problem.
Right. So actually, there's a good follow-up question from Apurva Agrawal. And she's basically asking, say that you use Java 8 at your day job, right? And the question is what's your advice on staying up with the latest language version or the latest technology when you may only be using something very specific like an older version of Java at your job?
Right, and thanks for the question, Apurva. And I'll just say, almost every job I've gotten was based on what I did on my own, and almost never what I did for my company that I work for, or even a client that I work for. And to me, that is the incentive, because and this is a bit shocking. 35 years into it, I look back at time. My first job was using C++ and using database code, never did a UI. And I went out and learned UI programming on my own. And then the next job I got was programming UI. Then I went and learned Java on my own. The next job I got was programming in Java. And so even across languages, that was necessary for me. And but on the other hand, when you're working on one version of Java and you want to learn something else, maybe a newer version, there are two benefits to it. One is you stay abreast as to what's happening. If you have to go find another job, or within your own company, if there's a newer project, it makes you more valuable. Second, more important reason for me is, as an example, let's say I'm learning about records. I'm like, oh, I know what records are. Oh, I just learned about destructuring. Well, I'm writing code in Java 8, but we're going to move towards this in a few years. Let me write the code in a way it becomes easier to move towards it. And so knowing something helps you prepare for it. And as an example, right, one of the courses I teach recently, I give a particular problem, and I tell the developers, well, if you're in Java 8, here's how I would solve it. If you're in Java 12, here's how I would solve it. If you're in Java 15, here's how I would solve it. And so given these three solutions, maybe I will favor this one. So in the future, if I were to move to a future version, it becomes easier to change. So you can start applying some of those things as well in preparation to where you're going, and that can be really beneficial as well.
Right, and that actually you bring up a good point, which some people may not be aware of, which is since Java 11, someone correct me if I'm wrong, since Java 11, they've had this new 6-month release cadence, which I think it's almost exactly what you described in some ways. Instead of waiting 3 or 5 or however many years for the next major version of Java, we get this kind of small steps up, so that records were in preview in 14, but they weren't finalized until 16, I think. I can't remember off the top of my head. But anyways, the point is that you get to look at records, and yeah, it may not be final, but you get an idea of this is what records look like or will look like. And of course, they made a few tweaks along the way with records until they were released or finalized. But I think that's a great point, that learning these things in advance of when you may actually be able to use them is super helpful to designing code today, where you can use those new features without doing major refactors, right? Because if there's anything that programmers love doing is refactoring code endlessly, right?
Totally.
So that and unit tests, but we won't talk about that yet. We'll get to that in a few minutes. Yes, there's a question in the audience. Go ahead.
Yeah.
Okay, hold on, let me repeat the question. The question is if your company is on Java 8, would you recommend upgrading to Java 11 or 17? And what are some gotchas along the way?
I would say, so we'll get to the gotchas in just a minute, but generally speaking, our conventional wisdom is be incremental. But in this particular case, if you're on 8, your major jump is 11, because you're going to get into modules. 9, which is where the modules is. But here's the problem. When you go to 9, you're going to go to modules. And then you go to 10, you find out that some libraries or packages don't exist. And then you go into 11, this is like taking a beating several times over, right? So this is where the conventional wisdom doesn't hold. My recommendation is take the beating once and be done with it. So go from wherever you are to the maximum you're able to go to, 17 in this case, and go through the shock once and figure out what's missing and be done with it. So that would be my recommendation. Now the gotchas though is, what's going to make you do that or not is the dependencies. So you might have a dependency that works with one version of Java and not the other, and now you have to figure out, well, I want to go as far as I want to go, but what's going to limit me? And if your dependencies limit you to, for example, Java 11, well, go 8 to 11 then, not to 9 and 10. If your dependencies don't hold you back, then go as far as they will let you go. That would be my recommendation, is to just deal with it once. And then once you go there, the key there is not just to go from 8 to 17, but as much as possible to be able to keep up with the versions as you go along. There are two ways to look at it. One is you can say we want to change the version and use the newer features, which is great. We're able to use the newer features, but if your production is in an older version, you can't use newer features. But what you can do though is you can set the source release version, and you can still use a newer version for development, but build for an older version. So that gives you the best of both worlds. You know that your binaries will compile and run in a newer version, but it prevents you from using the features that are available only in that version, because you tie your release version to an older version. And I would highly encourage that. If your production is not able to move, at least move your development as much as you can. And that gives you the ability to say, when they are ready to move forward, it becomes an easier transition for you to move forward as well.
All right, so again, as a reminder for the folks in the room here and also out on YouTube, please ask your questions in the chat. If you're here, obviously, just raise your hand. We'd like to line up some more questions. We still have plenty of time. But the next question we have on deck is actually somewhat related to what you were just talking about. And it's from Daniel Hinojosa in Albuquerque, New Mexico.
Oh, no.
I don't know if you ever met this guy. But so he's asking about the recent Log4j stuff. Right. We're not going to get into the minutiae of that. His question is actually good. Otherwise, we wouldn't have picked it. Which was, we have this emergency fix we need to do in a library, right? Or we need to patch the library, whatever, right? Upgrade to the latest version for security reasons or whatever. So he's asking, what is your preferred way of tackling the mechanics of doing this upgrade across your systems, right? So are we, first of all, he asks, would the module system have helped? That came in Java 9. And then, you know, is better CI and CD a good way, right? Essentially, how would you go about tackling something that is on the scale of a Log4j, which you're using in every project in your company, right? What's the Venkat way of approaching this problem?
So he's always trouble. So I'm going to kind of take it on a tangent a little bit. And so it really comes down to agility, in my opinion, right? So agility is our ability to respond to change. And the key is, it doesn't really matter what it is, but we can never anticipate what's going to happen. Right? That's the world we live in. And if it's not this, it's something else. And the question is, how are you going to address it when something like that blows up on your face? So it really comes to agility. And the answer to that is, be swift, attack the problem head first, and find out where your touch points are, and start addressing them. There is no one answer that says, if you're using modules, the problem won't exist. Actually, that's not true. It will exist, because modules doesn't encapsulate it. Modules just gives you a better way to, break your code apart into manageable pieces. So modules, I don't suppose is going to really remove that problem for you, right? In the way that I can think about, it wouldn't. If you're in an enterprise, the first thing I would say is, if you reduce your dependencies, that helps a lot. I mean, I can tell you how many times I see developers use logging because they can do logging. Does your requirement really say that you need to log those things? Have you encapsulated things properly, right? That's a fundamental software design principle that you want to think about. And if you've done fairly good encapsulation, it's not a technology, but it's a way of life, it's a way of practice. And if you're encapsulating properly, if you tighten your access to things very thoroughly. If you don't take an easy route and instead you say, hey, I'm going to receive this request, but I'm going to encapsulate, and today I'm using log4j, but if I don't want to use it or use something else, how am I going to go back and use the code?
Obviously, the answer is to build your own logging framework or logging
No,
wrapper.
I wouldn't recommend it. But substitutability, right? We talk about that, decoupling and encapsulation. So my answer is, if we follow good design principles, I think we are better off dealing with this already, or even preventing it to a great extent, I would say. But going on a little bit of a tangent, I'll say something else. And again, my goal is not to blame people who have done things, but here's another thing as an industry I think we should really be sensitive and think about. So I was mentioning this yesterday in another session. Imagine I'm your neighbor. Sorry that you have to imagine I'm your neighbor. And I come out and I find that your garage is left open. There are two things I can do, right? I can call Pratik right away and say, Pratik, your garage is open. Should I close it for you, right? As a good neighbor. Or I can post it on Twitter. And I can say...
Wait, I'm sorry, post it on Twitter. Okay,
yes.
Continue.
And oh, did you guys know that Pratik left his garage open? In case you're wondering, here's his address. And just saying. And that's another way to do it. And you may find out that your garage is left open, somebody
because
tweeting
your car is missing.
Or other things, more valuable things missing, right? Something to think about, right? So when you find, I remember...
Hold on, the third option there, though, is just to close my garage for me.
Absolutely, right, if possible.
Right.
Or at least be responsible to say, hey, I closed it for you. Hope everything is okay. And in case you need any other help, let me know, right? A few years ago, this actually happened. There was a day when there was a breach in Ruby on Rails, and they sent out a notice saying, upgrade now. And people said, why? And the answer is, don't ask. Just upgrade now. And they waited for about 2 or 3 days, and then they revealed what the problem was. And I have a lot of respect for that, because you are reasonably giving time for people to say, we got a problem, and I'm going to give you a time to run before they hunt you down. And something to think about, right? Yeah. So we need to think about the overall impact we have on the societies. I know people who couldn't go on their vacation with their families because their boss said, oops.
Because of this log4j CVE that came out last week.
Yeah. And you're affecting people's families, people's lives, people's living, and is it worth it?
Yeah. No, you're absolutely right. There's been a lot of chatter within the Java worlds that I live in about exactly what you said, and why did this drop on a Friday, and couldn't, like the Ruby thing you mentioned, could they not have just said upgrade to this immediately, or went to the log4j maintainers and say, hey, you need to fix this right away, and tell everybody to upgrade immediately before we go and reveal this exploit. And I was reading something basically on Friday where it looked like almost every large to small to medium application had been tested for the exploit by people looking at their logs. So this picked up very, very quickly across the entire, across the entire internet, basically. So that's actually a really good point. One other thing I wanted to ask you about, or have you expand upon a bit, was you mentioned practices, right? So Daniel mentioned about CI and CD and things like that. So we're not going to stand on the soapbox and preach that you must have CI, CD. Everybody knows that, right? But if you don't have something like CI and CD built into your organization today, and you come out and you see this kind of exploit, and you're like, oh my God, we have to fix it. Well, what are some things that you could do as a developer or DevOps person or whoever to attack this problem head on, knowing that you don't have the CI and CD infrastructure to be able to test so quickly and push to production so quickly? Are there any things that you could suggest for folks that are in that unfortunate situation?
So you're talking about after the fact or proactively?
No, after, like, this CVE just dropped. on Log4j, but we don't have CI and CD. What can I do to make this go as fast as possible and patch and stuff like that?
I don't think CI and CD actually matters in this particular case, right? Because to me, CI and CD is where you are keeping track of regression over time, making sure things work properly across environments. In a way, I would say a crisis like this really it's orthogonal to the CI/CD pipeline issue. You want to be able to hit the problem head on. First, hey, let's go ahead and find out if our system has this vulnerability. That's the first thing I want to find out. And if it does, start fixing it. And then, the next step, of course, is if you're a library, if you release a library, you got to get a newer version out to people that are using it. And that's your first step. If you're a product company, you need to go make sure that all your, services that you're running are upgraded. Sure, if you already have a process to do an automated continuous deployment, you are well ahead of the curve. If you don't, well, you already have whatever your methods are, right? If they could be elegant, they could be manual, they could be torturous, but you're doing it already. And the question is, once you find what the problem is, use your methods to go upgrade as soon as possible once you find that there's vulnerability in it. If you don't find the vulnerability, then examine more thoroughly. Start by looking at the dependencies, start looking at, if you look at the articles and things written up, they talk about, hey, if you have these dependencies, the likelihood that you have these kinds of problems, examine those things. So you could do a quick examination of your dependencies and find out if you have the necessary libraries in the path. And that could be a way to say, even though we are not able to detect the vulnerability directly, we want to be cautious about it. Can we remove it? And if you have a fairly good amount of automated testing, run that test to make sure your product is still working after you make the change. And if you don't, well, that's the cost you're paying for lack of sustainable agility. Then pay them twice, pay them n number of times to get that quickly tested.
Yeah, so on the last note, for this year's DevNexus, we're going to print up a new t-shirt that says, I don't normally test, but when I do test, I test on production, right? So just, or we'll go with the Log4j t-shirt idea that somebody had. So I don't know.
Hey, at least you're testing in production. I'm good for it, right?
At least you're testing somewhere, right?
That's right.
All right, so let's switch gears a little bit, Venkat. The next question we have from VGP is, can you share your view on prospects of Java for AI and ML?
Oh, gosh.
Let me start. How's that?
Yeah, go
Give
ahead.
you a second to think.
Yeah.
Okay. So I've been doing some work in this area recently, and there's stuff has slowly been coming into the Java ecosystem for doing AI and ML, right? There's all sorts of different small libraries. In my opinion, they're not at parity with what you get in the Python universe. That may be a little bit of an understatement, but anyways. But where I think that Java specifically can excel, and especially if we bring Kotlin into the picture, is that the folks over at JetBrains are actually doing some really nice work in this area for producing libraries in Kotlin to do data engineering and also kind of coming up to the edge of AI and ML. But there's still a lot to be done, in my opinion, at this point in time. So I actually have a presentation on data science on the JVM using Kotlin and Apache Zeppelin, but it feels like, to me, it feels like Java is a natural fit for all of these things, especially when we consider that some of the nuances of Python, right? I don't want to talk bad about Python because it's a great language,
sure.
Right? But there are differences between Java and Python. But there are libraries, for example, there's something called Krangle, which is similar to Pandas. But it's available for Kotlin, not necessarily for Java. But anyways.
And that's exactly what I was going to say is, I say the reason for my gosh was, it's not a language issue at all. It is really a question of library issue. And libraries are created by active users, right? And not by the stewardship of the language developers. And it's kind of like talking about Spring or Quarkus or or log4j or any other library you may want to think about.
I still use struts, but please continue.
I refused to. I saw there was a static. I didn't hear it. Sure, why not? But the point really is that Java traditionally has had some amazing libraries around it, right? That's the beauty of the ecosystem. And I think it's a question of time before that happens. And as more and more active developers are developing AI and ML related applications, they might start developing more of these libraries. And there is nothing that stops Java being used as an active language in this area, because it's not a language issue. Language doesn't make it either easier or harder, except maybe I would say one thing. One of the things that you get benefit from, not just Python, but Python-like languages, is that it's very flexible. There is less of the ceremony, and the ceremony is not because of Java, but the ceremony is because of static typing. And there are times when you are experimenting, you are trying to say, let me see if this will work. And it doesn't help for a language to say, but before you try it, can we be formal about the types? And you're like, but I don't care about it right now. So I think the reason for the popularity of Python in this particular case is that applications like AL and ML lend themselves for more experimentation, more heuristics, and what you want is less ceremony, less rigor. And but on the other hand, once you get something into production, you might want that rigor, you might want that verification. So it's a balancing act that you're really looking at. And as time goes on, when we realize that we have figured out how to really create these models, maybe we'll be more inclined to have more libraries in Java to do it.
Yeah, and I think aside from the language part, the ease of going from A to B very quickly, low ceremony, as you mentioned. For me, I think the much bigger thing, this is my opinion, is that the libraries that are available in Python for doing scientific computing, AI, ML, the libraries are amazing. They're super easy to use, they're very intuitive, and it's like, well, obviously I'm going to use this because I can go and do this task or this feature very quickly.
Yep.
Without having to write a lot of low-level code. I can work at a higher level abstraction, and if your primary job is not as a programmer but as a scientist, let's say, it's like, well, what are you going to use? The answer is obvious. I'm going to use something that's easier for me to think about and to go and build out quickly, right? Rather than having to spend a lot of time programming and coding. So, yep.
Yeah. And just to add on to it, I completely agree with you. And I think a part of the problem there is it's also a self-imposed structure that programmers have created around them. I wouldn't blame that on the language. As I work with developers, I would say, but why are you doing it? And they were like, because I should. And it's like, no, you don't have to, right? For example, going back to your example of Kotlin, Groovy, Scala, Clojure, almost all these languages, you can create functions. You don't need to create classes. And there is so much of structure we build around in Java, around classes and around interfaces, that's simply not needed in those languages. So maybe that'll lend itself a lot more because you can get to your work quickly rather than trying to put the structure around something before you can get to what you want to do.
Right. Absolutely. All right, so we have a question from Venkat here, not this Venkat, another Venkat, Venkat in the audience, which is currently Java 11 LTS is still not end of life, of course. We, on the other hand, have Java 17, which is now LTS. When do you think is the best time to start migration to 17 from 11? Right, and basically he wants to talk to his leadership about, this is when we should make the jump from 11 to 17.
I would actually flip the question. Don't delay unless you have a really good reason to delay. And in fact, we're going on a 2-year cycle now, not a 3-year cycle.
I don't think that's finalized, but yeah, that's in the works.
Yeah, that's kind of where we are heading. So the sooner we start migrating, the better it is. So I would say, what is the reason to stay behind in 11 if you can go to 17? If there is no good reason to stay behind, then I would say move on. If you have a good technical reason, Well, those are the reasons that are going to hold you back anyways, right? So nothing artificially says you have to cling on to 11 as long as you need to. So your dependencies could be an issue. Right. Or one other thing that often limits companies from moving is the lack of testing. When you do make a switch, you got to incur a lot of expense in testing. If you don't have automated testing, that could be another reason that's holding it back. Well, unfortunately for that, you're going to hold on as much as you can, and when you're forced to, you're going to move and take the expense one time. But I would say in that case, start moving towards automated integration testing, where how much ever possible. Then that removes that burden of retesting, or at least eases the cost of it.
Right. Yeah. No, that makes sense. Something I'd like to add to what you said is, all the points you made were great, but when I think about taking an issue like this to leadership or management or whatever, the other thing that I think may be helpful here is, well, we can start using these new features of Java.
Sure.
Like records. It's like, we don't need to pull in an additional library like Lombok just to use the data classes. We can start building stuff out or migrating to records. We don't necessarily have to refactor existing code, but at least new code can use this new idiomatic way of doing data classes in Java, which is records. And we can start using the new switch expressions, for example, which I'm a huge fan of. 'Cause I purposely avoided switch statements in Java because, well, not too much ceremony, too much noise, a little bit too difficult to understand and reason about, because it's like but one of the parts of Java which I feel like not really object-oriented, much more procedural. Sure. It's like,
and buggy as well.
Yeah, and can be buggy, right?
Yeah.
So it's like, wow, if I can start using switch expressions in my code today, it makes the overall quality of the code better because I'm using expressions instead of switch statements.
So one thing I would add to that is, especially talking about leadership, a lot of times the leaders care about money, as they should, because it's a business decision. And the business decision reasoning I would give to them is, you got an option. One is, they say, we're going to take this end of life, run. And now you got to rush to do this, or you give yourself more time right now because you're not under pressure. This can happen as an incremental approach. You can take a little longer, you're not under pressure, rather than saying, drop everything else, do this. And from a business point of view, if I can give you this upgrade while delivering features, that's a plus. Or I can say, sorry, we're going to deliver fewer features in the future because we got to move this now, right? That to me is a very important discussion to have, because it gives you a financial advantage to incrementally move rather than being forced to move.
Yeah, no, that's actually a really good point. We have a mutual friend, Ken Cousin, who wrote a book recently called Helping Your Manager Help You. Is that right?
Yep.
I like the old title, which was Managing Your Manager, but whatever. But he spoke at the Jug back in August, and one of the points that he made was that your manager has different priorities and goals than you do as a software developer.
Totally.
So it's not enough for your manager to build a bridge to you. As a developer, you also need to build a bridge and understand what management or leadership's priorities are within your company. And I think that's a great way to build up a use case, right? Basically taking off your software developer hat for a minute and think, what does my manager get out of this if we go from Java 11 to 17? It's exactly what you said. We can either rip the Band-Aid off, 3 years from now, or we can slowly work towards keeping everything up to date so that we don't have to spend an entire month or 3 or 5 months, whatever, trying to upgrade, because now this thing is all of a sudden, EOL, and we have all this technical debt we built up on top of that, years and years. Why not do it slowly over time, et cetera, right? And
just to add, that's such an interesting question, and add to one more, you kind of prompted me to think about it. One day they wake up and say, oops, you got to upgrade because we got a security flaw, for example, right? Let's not wish that coming through. But one thing is being able to and not doing is very different from not being able to. So I think there's a technical incentive as well, because if you're able to move forward, almost always when there's a problem, we're going to go to a future release, not a backward release. So it's important to be able to do that as well.
Yeah, absolutely. And especially with what we've seen with the recent Log4j issues. The Log4j is probably not a good motivator for staying up to date necessarily in your code base, because it doesn't have like a huge dependency type of, basically the API hasn't changed in decades, right? But for other things, definitely, it's, you know, we've seen it here in Atlanta with stuff that's happened with local companies not upgrading certain versions of certain web frameworks, which we won't mention right now. But yeah, staying kind of on top of things and being able to take something out and plug it in when an emergency happens is definitely a big deal. So,
and older version is a technical debt.
Older version is a technical debt. That is absolutely true. Yeah. But then the question kind of becomes, right, and I'm going to put you on the spot again, which is in any sizable Java project, you have a lot of dependencies, right? Because one of the great things about the Java ecosystem is that there's so many libraries, high quality libraries, so you don't have to do a lot of the low level coding. Use a library to do it, right? Makes total sense. The problem is as again, in any real Java project, you're going to have a lot of these dependencies, right? So sometimes as a developer, I feel like you're just running on a hamster wheel, upgrading dependencies all the time. Is that what it's really like, or like how do you think about this? Like how do you think about this?
I'll share with you a story I always refer to when we talk about dependency. I was visiting a team, and this is not Java, but it applies equally to Java, I think. And I was talking to the developer, and the developer said, well, we quit running all these automated tests. I said, oh my goodness, you quit running all these automated tests. Why do you do that? Oh, we upgraded some dependencies, and the test didn't work, and we don't have time to fix it. And I said, okay, well, how many dependencies do you have? And then without missing a beat, he said, oh, we got 150 dependencies. And I said, wait, I know what your application is doing. For the front end you are building, I cannot for the life of me imagine you will need 150 dependencies. And he just, listening to me, he opens up the build file and shows me, here, you take a look at it. And sure enough, there's well over 150 dependencies. And I looked at him and said, why are you using 150 dependencies? And he said, because we found them. And I'm like, okay, I'm glad you're at least being honest. And that's one of the problems in our industry is, part of what we do is infatuation. So I want developers, this is an architectural concern. I want you to think about three things. What's the cost of bringing a dependency? What's the cost of upgrading it? And what's the cost of removing it? It is way easy to add stuff, but incredibly difficult to remove stuff. And so we often are short-sighted. We say, I don't want to do this, so I'm going to bring in a dependency. I'll be absolutely blunt about it. I wanted to do one particular feature, and I said to myself, if I want to do this feature, it's going to take me maybe 10 minutes to drag a library. And every page on the web says, run this command, do this configuration, write this one-liner, boom, you're done. Tempting. 10 minutes, boom, I can do it. And I said to myself, okay, fine. But if I'm not going to do that, how much time and effort it's going to take me to write that code myself? And I said to myself, I'm going to time box it. I'm going to give 30 minutes. The reason is, I don't need everything this library does. What I need is something very, very small. I'm going to time box 30 minutes with automated testing. And I did that. 30 minutes, feature working, and a month goes by, it was not sufficient. And I said to myself, now is the time again to evaluate. Are you better off bringing the library or doing it yourself? And I said, to make this change, I need 10 minutes. Let me give it 10 minutes. If it doesn't work in 10 minutes, I'll bring the library in. That decision, right? So defer that. The question, one of the key features in architecture we want to ask is the idea of reversibility. Reversibility is, how easy it is to reverse out of a decision. What does it cost you to say, oops, that was not a good idea, let's reverse out. And we need to consider reversibility before we bring in libraries. And if we do that, then we're going to have fewer dependencies in our application. We are going to ask the question about whether we need it, not whether we want it. But the problem is English is a very fluid word. I was at the grocery store 2 days ago, and I literally heard one guy said, we need chips. I'm like, I was almost tempted to go tell him, sorry, that's wrong English. You never need chips. You want chips is a I don't want to argue with you want chips, that's perfectly fine. But needing chips, I don't think so. That's the problem. We think that we need dependencies when we want dependencies. And I want to really take the time to separate that out, and we'll have fewer. There's no substitute to doing that, I think. If we go through a fairly rigorous process, then I think we will have a lot fewer dependencies than we do today.
Right. No, that makes sense. And you're right. You don't need chips, but I will say you need chocolate, but that's a different story. So. All right. So the next question is about experience dealing with distributed caching issues. I don't know if we want to tackle that. So I'm going to ask a totally unrelated question, which is when we're thinking about, so it's the end of 2021. Right? We're moving into 22. Hopefully 2022 will be much better than last year and the year before that. But when you put your thinking hat on and you think about what are some of the trends in 2022 that you're excited about, some of the things that you're looking forward to in terms of the Java space or the tech space, or whatever, right? So what are, if you look into your crystal ball and you say, wow, this is something really cool I think that's going to happen next year in the programming space or Java space or tech space, well, what are some of those things?
I think overall we are seeing a lot more maturity of certain technologies in terms of adoption. At least among my own clients, I'm seeing a lot more traction towards effectively using reactive programming these days. I'm seeing quite a significant trend, at least among my client base. Huge organizations, banks, high volume processing organizations.
Okay, let me stop you there for just a second, and let's talk about reactive programming for a minute, okay? Because we were talking about this with Venkat before the session started tonight, and the feeling that some of us have right now, right, and this is just a feeling, right,
sure,
not fact, is that we seem to have reached the tip of the hype curve with reactive programming, and we're on the way down. So everyone knows the tech hype curve thing, right? Well, it looks more like this, but do you really feel like reactive programming is something that is in that long tail of adoption right now, or like how many organizations are really seriously starting to implement or have started to implement reactive programming, right? And when we say reactive programming, we mean things like Vertex or Spring Reactor or micro-profile reactive or whatever.
Sure, yeah, and quite significant. That's kind of what really excites me. I've been talking about this for a few years, as a lot of other people have, and we went from let's test the waters to what is it, and then we had this architectural push behind reactive programming, a lot of hand waving, if you will, and now we are come down to the API level, and I've got organizations asking the question, when should I use it? Or how would I convert this library of code to this? And I'm actually currently working with a few organizations that are in active migration of their code base to be reactive, where they have very specific use cases where they will benefit from this.
Okay, 1 second real quick. Let's just take a step back for some of our audience here. What are the key benefits that the people you're working with, what are some of those benefits that they feel like they get when they go to reactive for this specific feature or this code module or whatever?
Right, and that's really the most important question we need to understand, right? Because if we don't, we are using wrong tools for the wrong purpose. So I would distill it to 3 things. And the first is, if you have a stream of data, then you may want to consider reactive programming. So
Streams, yep.
Streams, right? And this really nothing new. We did this back in the 80s, right? We called it data flow computing back then. And you have a stream of data, and you want to be able to deal with the stream of data. So you have a stream of data, you probably want to look at reactive. The second is you really want to handle back pressure. So you have a very varying degree of flow, and you want to decide how to handle it, right? There's no one shoes that fits all. Your business process, your use case decides what to do. But you have a back pressure, you probably want to go reactive.
Right, and the way that reactive helps with back pressure is that it offloads stuff off of synchronous threads and more onto a network queue kind of strategy.
It could be potentially. That's one
Right.
strategy. But
Right.
there are among, and the beauty is it allows you to pick the strategy that may make sense to
Right.
you. And a third reason, which is kind of where I look at how Spring, one very simple example is you got a function in Spring and a controller that returns an employee. Why in the world should return a mono of employee, right? And that's a very genuine question, right? Oh, you got to use mono because everybody uses it. No, it's got to be a good reason. Well, the third reason is it's easy to become asynchronous, non-blocking. And the non-blocking nature, to me, is quite valuable. You make a request to an API, you don't want to wait on the response, you can just release the thread and go off and do other things. When the response comes back, you can carry on to do what you want to do. But then, where it's possible, you can be end-to-end asynchronous. And we're not there quite yet. So in terms of the hype curve you're saying, that maturity has not happened on the database side, the relational database side. We're getting there, but I think we're about 2 years away.
Okay, right. Sorry, I know we keep taking these little tangents, but we want the end-to-end reactive asynchronicity. And you just said that we're not there on, basically, let's call it the bottom, which is where we touch the database.
Right.
But I thought that we have these reactive database drivers already.
Not mature.
Not mature.
Yeah.
Okay.
And I would not recommend jumping directly into production with it today. Your mileage may vary, but I would be very cautious doing it. So while the front end is reactive, fairly stable and mature, while the middle tier is fairly mature and reactive, I would say the deep end databases are not. If you're using a NoSQL database, far more mature compared to relational databases. So I'm thinking maybe another 2 years, 3 years before that gets really mature. But that's the beauty, right? You can be end-to-end reactive and asynchronous. And then the question to ask is, are any of those really important to your application? It really comes to your architectural characteristics. If your architectural characteristic demands it, then you can provide it as a use case. I've got clients who are saying, we needed this, and here is how we have implemented it. And they show me what they have done, and then we refactor it, and it fizzles down to a very elegant, simple code, and you're like, wow, I did not have to do so much work to achieve that, right? Using a hodgepodge of other technologies that are available today. That's kind of where it really, so if you have a need for any of these, and if you're already doing this in other ways, you can benefit from this. And that's one of the reasons why it's important not to have an infatuation towards it. When people say, there are times when I would look at an API, it's like, why did you do it this way? Well, because we want everything to be reactive. Like, no, you don't. That doesn't give you any purpose. You only complicated things.
Right, and again, we're taking a little bit of a tangent here to help our audience understand this. Why do you not want to do reactive sometimes?
For one, it is a added set of overhead and functions, and not everything needs to have that functional pipeline. When you don't have say you don't have need for asynchrony, say you don't have a need for streams of data, then you took a very simple request that gives you a piece of data into now a pipeline of operations, and then when you're done with it, what have you achieved with that, right? It's kind of like using a sledgehammer, well, but you didn't get the benefit out of it.
Yeah, exactly. And this is, when I talk to people about reactive, and sometimes, as you said, people get very excited about this new technology, this new golden hammer, as we call it sometimes. And I tell them that there's nothing simpler than doing line of code 1, and then 2, and then 3, and then 4 and 5, etc., as opposed to having that, kind of reactive, having the plate spinning in the air as you do with reactive.
Totally. And the question really to ask is, these are the different paradigms. And believing that one paradigm or one way of doing things is the right way all the time is a problem. And I think we should really find the balance and pick and choose the right option to use based on the problem at hand. Then when we do use a particular approach, we are convinced why that's the right approach. And we are also at the same time willing to change to something else when that's not the right tool. And believing that there's one way to do everything is quite a dangerous thought.
Right, absolutely.
The question that I keep getting is Loom. So we'll go back,
Okay, so question that we've been getting in the chat is, okay, so we have these reactive frameworks, right? We have actually several very good ones in the Java universe. But what about Project Loom?
Yeah, so let's take a step back for a minute. When you, I came from a background of imperative style of programming. And I have some good friends who believe that functional way is the only way to do things. We're still good friends. We go to lunch and dinner together, but we agree to disagree on this. And to me, these are vehicles or tools, and there are times when one tool is a better choice than the other. If you are programming reactive stream or completable future, right? To me, the difference between completable future and reactive, there's a lot of differences, but one key difference is in a completable future, you have at most one piece of data going through the pipeline.
Yep.
In a reactive stream, you can have 0, 1, or many, right? And other differences. But if in both of those, I was working with this for a while and called me silly, but one day I literally screamed out saying, oh my gosh, reactive programming is functional programming plus. Because what you're really doing is you're laying out a functional pipeline. And once you lay out a functional pipeline, you're just transmitting data through that transformation, which is great. I love it. And I learned functional programming after decades after programming imperatively. If you wake me in the middle of the night and say, what do you think about it? I would love it. What I love about functional programming is it removes the accidental complexity in your code. But we also have to genuinely ask, when is it that a functional pipeline is a terrible idea? And the functional pipeline was really designed with the mathematical underpinning. And almost, not all, but almost all mathematical operations are pure functions. Right. But when you...
Right, so when we talk about functional programming, some of our audience probably know this, but we'll say it anyways. A lot of, everything in computer science, but especially when you start doing functional programming, is couched in category theory and algebraic computation.
Right, and so that's great, but if you're going to perform I/O operations, for example, or if you're going to call into a web service, you're going to do logging, or you're going to read a user's input, all of these involve exceptions. And a business logic may have an exception as well. Unfortunately, as powerful as functional programming is, the functional pipeline is terrible to compose a pipeline of exceptions. Reactive programming handles it a little bit, but the problem with the reactive programming API is better than Java 8 streams in that regard, is they give you the data channel, error channel, and the complete channel. So if you have an error, you just straight away go down and handle the error. But the reality is, in our line of work, you do something, if it worked, you go on to the next step. If it didn't work, you take an alternative, and then you try again. And if that works, you move on. Otherwise, exception, you take an alternative. So this is break and proceed, break and proceed. It's incredibly complex to write the code for that in functional pipeline. When you start doing this, you lost all the benefits of functional programming, your code turns into a monster, and you look at this and say, why am I doing this? And then you suddenly...
It's difficult to understand,
It is difficult to understand, it's difficult to maintain. And now you say, oh gosh, writing code imperatively is much better. So then, reactive API is to functional pipeline as to Project Loom is to imperative style of programming. So what Project Loom says is, fine, you want the asynchrony that you want from reactive programming, great. I will give you the asynchrony, but you go write the code the way you normally write, with a try and a catch and exceptions. But when you make a function call, we will not hold your thread hostage. We will release your thread in the background. Your thread can go do other things. When the task you requested completes, then we will pull a thread from the virtual thread pool and work on the next. So in Project Loom, your task is blocked. Your task always blocked. Your task is blocked, but your thread is not blocked. So as a result, you are able to get a better throughput. But it becomes easier to express your idea because imperative style code is actually good when your code has a lot of exceptions. So this gives power to you as a programmer. You can say, hey, my computations are pure. I don't need to handle exceptions. Well, go use your functional pipeline. There's nothing wrong with it. Or you say, oh, but in this area of code, I got to deal with a lot of exceptions. Well, then don't, torture yourself with the functional pipeline. That's a great tool for another place. Here, use Project Loom, and you can do the try-catch with your imperative style programming and get the same benefit of asynchrony. So you don't need to suffer the consequence of callbacks. So here's another way to think about it. Why did Java provide promises, and why did they provide async and await? For exactly the same reason. Because promises are great when you want to deal with the functional pipeline. But the functional pipeline becomes horrible with the then and catch and then and catch, and you're like, my gosh, I'm not able to keep this in my head. And when we do something absolutely silly, we give a nice name for it. People call this a railway track pattern. Well, yeah, it sounds fancy, but the problem is it becomes horrible after a while. And then you say, gosh, I don't want that. I want just to write the code, it's easy to understand. Async and await literally use promises behind the scene, but remove the burden of the functional pipeline. That's exactly what we are coming to. It's kind of funny, right? Completable future is equivalent to, in Java, is equivalent to promises in JavaScript. Now Project Loom is kind of bringing that into the async and await kind of, even though semantically they are very different under the hood, conceptually that's the same idea. So you get to choose a functional versus imperative where it makes sense, reactive versus Project Loom.
Right. Wow. That's a lot to take in. I may have to go rewatch that later to fully understand what you said. But it doesn't matter to me anyways. All my methods start with the method signature and then a try block, and then a catch at the end. So it doesn't, I'm joking, of course, don't do that. But
empty catch block.
Empty catch
That's
block,
it.
yeah, of course. Empty catch block. You don't need to catch exceptions, right? Doesn't make sense. So we did have another interesting question here, but if we go back to my original question where we started down this path, which was, what do you feel like in 2022 are some interesting trends, things you're excited about, crystal ball? We talked about reactive. What else was there?
Asynchronous programming. I think that's going to become more mature. I'm hoping people will actually start doing real microservices rather than
real microservices. Okay.
I'll share with you this story. We were at a meeting a couple of weeks ago, and the team was describing what they were doing, and I said, "Okay, got it. What you're doing is an application with a bunch of, web services." And then we discussed it a little bit more. And then the person said, how do you describe this architecture? I said, you're doing an application with web services. And then he said, but why can't we call it microservices? So there's this infatuation to say, we're doing microservices. Everybody in the world cannot be doing microservices.
Yeah, some people are doing distributed monoliths, but please continue.
Oh, totally. And that's why I'm saying I hope people will start doing real microservices. And we are in this bandwagon right now that we got to call what we do as microservice. If everybody is doing microservice, something is wrong. And so I think we'll get more mature in the industry as to what we really do. And some of the trends I'm seeing is other products and tools. For example, like GraalVM or Micronaut or Quarkus. It's time for other things to gain their stage, I think. And I'm hoping that that'll happen in 2022.
Yeah, there's definitely been a lot of interesting new projects, like you mentioned just now, coming around the pipe or coming around the bend. And actually that leads us to a next question that we have from Mohsin Bhagwan, which is monolith versus microservices, what should we prefer? Based on that recently Shopify posted amazing results during peak Black Friday, Thanksgiving sale time, and they said that all their apps are big monoliths. So you just said you want people to do more microservices, and now we're hearing that like Shopify did everything with majestic monoliths.
Oh,
So-
I said I want people to do real microservices.
real microservices,
Yes, I didn't say
sorry.
more.
Sorry, misheard you. So anyways,
I think that's one of the problems we should be very careful about. How many of us are Shopify, right? Not everybody is Google, not everybody is Netflix, not everybody is Shopify. And also, a lot of times we take these blogs or items and then we say, oh, they do it, so we got to do it. One other things I've been hearing a lot more recently is, we need to have a monorepo. Why? Because Google is doing it. The first question we need to ask is, what are our needs, right? What is my business needs? I think that matters a lot. I don't care about what Shopify's business, I would if I was doing work for them. But for my clients, for my company, what are my business needs? I think we should really focus on that. And then identify the architectural characteristics, and then ask the question, what is the right fit for that architecture? And modularity is a good thing. And if you can get that benefit using a modular monolith, that's fine. I have a few monoliths in production. I'll be absolutely honest about it. I have zero desire, need, or plans to change it. And you can ask me, how's it going? It's going great because I don't have a user base that Shopify has. I've got much fewer number of users, much fewer number of volumes than they need to handle. And so for my needs, it's great. And if it's for their needs, it's great. It definitely is for mine too. But if you ask me, what would prompt me to reconsider? And that would be the deployment issue, right? So I want to really understand why I want to use a particular architecture. What benefit does it give me? If those benefits are going to help my business, I want to consider them. If those benefits are not helping my business, there is a bigger cost to doing microservices. There is more complexity, there is more expense, there is more effort, and you're increasing everything.
Yeah, this is absolutely true. I'll just interject for a second here, that whenever you take a system that's not distributed to being distributed and elastic, you're adding a lot of, not incidental complexity anymore. You're adding that complexity in, right?
Actually, it becomes a little bit more complicated than that, because this is the problem with our industry, right? We are giving terms that don't mean what it means at all. I sincerely hate the word microservice because it's neither micro nor service. And we do this over and over. No SQL, why? Because it's not a no SQL, so we're like, no SQL. Wireless, why do you call it wireless to say you don't have a wire? Why can't you give a better name for it?
Wire free. Just kidding, please continue.
And we're consistent about this.
Right.
So the word monolith versus distributed, the problem really is my monoliths are distributed because I have services I need to talk to. And I do this for A, because of scale, but B, because of the domain. And so they are distributed. So the real word distribution versus monolith is really not in runtime execution, but in deployment. So a monolith is a single unit of deployment. A microservice, among a lot of other things, is multiple, meaning distributed units of deployment. But the complexity really comes in is you need observability, you need traceability, you need monitoring, you need a lot more effort in testing. So your production cost is higher because there are so many things you otherwise wouldn't do that you need to do if you're doing real microservices. And so then you have to ask the question, if I'm going to do all of these, it makes sense to do all of this when I have a business demand to do it. If technical people decide to do it and the business has no needs for it, that's not a professional environment. Because imagine somebody comes to you and says, you're going to pay for this, and when we are done with it, you will get no benefit. But we all had a great time doing it, right? And
resume-driven development.
Bingo, right? Exactly, resume-driven development. And that's what we need to really ask the question, are we really benefiting our business? So to me, the reason I would even go towards this technology is business agility. If the business agility is not needed right now, or that's achieved in another way, then I should have the wisdom of not using any of these. So I think part of our decision as a technical leaders is not what technologies to adapt, but to really challenge the decision and say, why are we adapting it, right? So the question often is what and how, but I think the more important question is why. Why are we adapting this? If I can write a half-a-page document explaining, justifying the reasons to use a technology, then I think we'll be a lot more careful. And sure, right, this is a good tendency. We all want to get our feet wet with different technologies, right? We have the desire to do it. But learning, I would say we need to learn 100 things and maybe use 2 of them in production. If what we learn is equal to what we use in production, I think we're in trouble as an industry, right? So it's important for me to learn a lot more. And so yeah, go build a microservice, play with it. User groups are for that. Come up with a team and say, let's get together on a Saturday, let's build a microservice, practice that. That's a great opportunity to learn. But then you go back to work and say, does it really make sense? And be the devil's advocate and fight for it and fight against it. Be objective on both ends. And then when you make a decision to use a technology, you knew that you did it for the right reasons.
No, that's actually great advice, right? A lot of times as developers, we forget that things need to be driven by the business or the business needs or requirements or all those kinds of things. So, all right, so we're at the end of time. I just wanted to give you a chance for your final predictions or anything else you wanted to mention before we log off for the evening. Anything else that you think, if you look in your crystal ball briefly, that's like, oh yeah, I'm really interested in that?
Well, definitely Project Loom is something I'm definitely
Loom.
interested in, and that's something I've been focusing on quite a bit. Maybe everything will maybe centralize into one framework in JavaScript? No.
One framework? No. Well, we're not going to talk about JavaScript too much here, but thank you for coming, Venkat. It's always a pleasure, and don't forget, we are on track to having DevNexus in person in April. We actually have Venkat lined up to do a keynote and some presentations, as well as a workshop on software architecture. So he'll be covering some of the topics that we mentioned here today during his hands-on workshop at DevNexus. So we'd love for you to join us in April for that, and we'll just do a fist bump here since we're still living in COVID times. Thank you again, Venkat.
Thank you.
And happy holidays to everybody. Thank you for joining us this evening. We hope you had fun.
Off air? All right. Thanks everyone for coming in person.
Thank you.